Hello and welcome to the latest episode of the Teardown Sessions. I'm still in my office at home, not in my studio, so you have to forgive the lack of beautiful fancy lighting. But we still do have a lot of really exciting things here on the show for you today. We are speaking with Ebrahim from Lime Microsystems, which I'm sure many of you are very familiar with. But before I bring Ebrahim on, I'm going to show you a few things that we've got going on at CrowdSupply. We've had a few busy months actually. So what have we got? So crowdfunding right now, some of my favorites. We've got a few projects crowdfunding right now, but I'll just take you over some of my faves. This is a book, and we do occasionally do books, yes, not just dev boards. And this is the new essential guide to electronics in Shenzhen. Now, those of you who are a little older may remember that this was originally brought to market by Bunny Huang, the legend, and it's been updated meticulously by Naomi Wu, who I'm sure many of you are also familiar with. Now, Naomi is a Shenzhen native, so this has been updated with maps, with with etiquette, with ways of talking to suppliers. So if you are heading over to Shenzhen for prototyping or to talk to factories, this is really definitely an essential guide. And look at it, isn't it pretty? I'm very excited for that to come out. Good job, Naomi and Bunny. Another one of my favorites at the moment is the Raspberry Breadstick, not just because it's a funny form factor, but kind of, it's an RP2040 dev board that fits down the middle of your breadboard, which I think is a very fun idea for teaching prototyping in the classroom. Look at that, it's nice and neat comparatively. Look, you can access a lot of the GPIO just from that one breadboard, so that's kind of cool. So if you're into education or you want a dev board for your RP40, I would definitely recommend you check that out. If you are a sysadmin, you may wish to check this out. This is a Pi-based where you can control your servers and your workstations over IP. You can do various things, even spin up your operating systems, blah, blah, blah. So check that out. We've got coming up two of my favorites. This lovely handmade wooden keyboard is coming soon from a very nice gentleman in Hong Kong who is really cool. And another super cool group of people who are working on something. Again, this is coming soon, so do subscribe if you're interested. This is an open source portable music player. Look at that chunky thing. I do like the tagline here, the music player you wish you had in the early 2000s. 100% open source, of course. And the creator of this, Jacqueline, is really good to follow on Mastodon if that's your social media poison of choice. What else have I got coming up? Oh yeah, this one's really nice. The Boondock Echo. This was one of the winners of the Hackaday Prize a couple of years back, and they're actually bringing it to market now. It's essentially an answering machine for ham radio devices, and I hope I haven't oversimplified that too much. But yeah, it's internet-backed recording for two-way radios. So definitely check that out. That'll be coming soon. If you're into ham radio, this looks like a definite purchase. All right, so without further ado, that's what's going on and coming up at CrowdSupply. I'd like to introduce my guest, but first of all, I'd like to thank our sponsor of today's stream, AMG. They have a program with us, so if you're using their products, they can give you a discount and they can get you parts and so on. So if you are considering a CrowdSupply campaign and you are using AMD projects, don't be shy and tell us, because we can get you cool things. So now I've told you about them. Thank you very much for sponsoring the stream, AMD. We are going to be talking to Ebrahim from Lime Microsystems. Now, I'm sure for some of you, the Ebrahim will need no introduction, but for those of you who are new to this work, let me just take this over, remove this, and let's bring on Ebrahim. Hello, Ebrahim, and welcome. Hi. So do you want to introduce yourself briefly, and we'll take the conversation from there?
Sure. I'm Ebrahim Busheri, co-founder of Lime Microsystems. And my background really is in telecom, in the design and implementation of radio modules and products for radio access networks. So I've been in this industry for over 35 years or so, designing for those kind of applications. So that's my background, really. That's where I come from. In the context of Lime, we formed the company back in 2005. And really the idea was to essentially come up with a single chip solution that enabled us to cater for all manners of standards and bandwidths and frequencies. So have a radio module that is completely software defined. So by the way of software, we can essentially cater for different wireless applications.
Very
so
cool.
that was the kind of plan for this company, and that's what we've been executing on since we founded the company some 18 years ago.
18 years ago. Wow, that's wild. So let's just take a step back. I'm sure most of the viewers today are familiar with SDR technology, but for those of us who aren't, well, I mean, obviously I am, but for viewers who aren't, can you just explain briefly what SDR technology is? Well, you know, like the broader explanation of it, so everybody's on the same page.
Indeed, I mean, the whole notion of software-defined radio has been around forever. Essentially, rather than designing specific circuits for different wireless applications, such as, you know, designing a radio that just does one air interface, for example, Wi-Fi, or it could be GSM or various other cellular applications. You have one hardware platform that attempts to cater for all these different standards. And as we know, wireless applications cuts across different frequencies, different bandwidths. The idea here to have a fully programmable solution, a single hardware that can be programmed in the field and could address all these different applications. Meaning that if you are doing, let's say, cellular 4G technology, you should be able to essentially change some parameters and essentially pick up FM radio off of the same solution out there. Obviously, there are a lot of challenges in implementing such a technology in practice. And you have a design that essentially could be overkill for various applications, and meeting the requirements for others are quite challenging. So software-defined radio, although the notion has been around, but it's taken a long time for it to materialize as a commercial solution out there.
So it came through. So before it was commercialized, was it primarily the people in academia and hobbyists who were making use of it without it being very good? Like, when did it start to commercialize?
Well, put it this way, defense and military applications have been working on this technology for quite a while. And traditionally, these were big pieces of equipment that essentially was designed to cater for a subset of air interfaces, or waveforms, as they call it. But over the years, to have a commercial device that could be deployed in large quantities, you needed to have a highly integrated solution and low cost, enabling the masses to be able to essentially access such technologies.
Very cool.
So when we started back in 2005, although the whole concept was in our mind as far back as 2003.
Who's our in this situation? Who's the beginning? At the beginning of Lime Microsystem, who is the us? Who is the we here?
Well, put it this way, I was, back in 2003, was running a design services company that essentially was working with large OEM or radio access network suppliers. And I was sitting together with a couple of our engineers and thinking about how we could optimize some of the designs that we were doing for them. And the notion of putting all of those circuitry into a single chip came about. I think it was summer of 2023 that the whole idea was born.
2023.
That's sorry, 2020, sorry, 2003.
Yeah.
2003. Yes, that's right.
That's 20 years ago.
20 years ago. That's what I meant. So literally, it took us up to 2005 to essentially solidify the idea. And we figured out a way of implementing all those circuits into a single chip.
So what was your first? I'd be really curious to know your early products and how they differ from your current offerings.
Yeah, that's a very interesting question. It takes me back a while, so I need to try and remember. But we really started the design work was almost towards the end of 2005. Mm-hmm. And it took us about 2 years to come up with the first generation device. So in 2009, at Mobile World Congress, we demonstrated our first chip. That was designed in a silicon germanium by CMOS process, by the way, on a 130 nanometer technology.
Oh, wow.
So we had a working chip essentially by the middle of 2009. So we were quite proud of the fact that we managed to put all those circuitry into a single chip. That chip was called LMS6002. Mm-hmm. That's when we actually started looking at the real problem of how we test such a chip for all the flexibility it had. When we were testing our prototypes, it was taking just over 2 hours or so to test all the features of that device. And that meant that this was not a commercially viable implementation. If you're having to spend that amount of time testing a chip. When it comes to mass production, any test time above 10, 12 seconds would cost a lot of money to do so. So in terms of test time, we really had to work on that product to get it down to a sub 10 second testing for each chip. And that took another further year or so to get it to that kind of a level. And we went to production back in 2011. So you can imagine it took almost 8 years from concept to a commercially viable design for a software-defined radio in a single chip. So it was quite a journey for us.
Was that chip still at 130 nanometers?
Well, put it this way, that chip is still in production.
Oh.
And we have a fair number of customers that are still using that device.
Wow, that's wild. I think of like 130 is relatively old technology now, but you can still do some, really great things with it. This Google Skywater project, I don't know if you were familiar with that, but that was all based on 130, and people were like, "Oh, 130, blah, 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 blah." But I thought, you can do some great stuff. Like you can do a lot.
Obviously, but I mean, actually, just to make a distinction between when you are designing analog and RF circuits.
Yeah.
You don't need to be on the leading edge technologies. A lot of the things that we do in analog and RF domain could be done even on 65 nanometer CMOS, and you don't have to be on a 7 nanometer digital technology that today is the workhorse of all these leading edge AI chipsets or processors.
So you don't need as much. And why is that? I guess because are you using fewer components? Is it mostly like what's the...
Well, put it this way, it's even more challenging for an analog and RF circuitry to be implemented in those kind of, let's say, 7-nanometer technology. There are a lot of design rules that limits you in some respect. And so analog and RF circuitry, the transistors are typically much larger than what you would need, because in the digital domain, you have a lot of chips, a lot of transistors that you want to pack into a single chip, meaning that you need really tiny transistors, and scaling of the technology is of paramount importance to be able to increase the integration level. Every couple of years, as you know, according to the Moore's law, we are essentially doubling the complexity of these chipsets. However, analog and RF, you have far fewer transistors. And design optimization around these larger transistors becomes much easier to design, especially if you're doing the kind of circuits that we do. We want to retain a lot of flexibility and performance over much wider frequency range, meaning that we can have some clear advantages of using these older technologies.
Yeah.
So, we are designing circuits that essentially today that for RF circuits that goes, or millimeter wave chipsets that goes up to 100 gigahertz. And for those, we are using silicon germanium by CMOS process.
Oh.
So these are, again, large geometry transistors, 130 nanometer. So these bipolar transistors with very high FT enables us to really push the frequency very high indeed and retain those kind of performances that we need for RF and analog circuits. So the story here is that if you're in the analog and RF domain, you really keep away from these state-of-the-art technologies that drives the digital technology.
Well, I did not know that. I'm not an analog person. I'm definitely like putting digital components on boards kind of person. So the analog side of things, it seems like wizardry to me. So that was very interesting to know. I did not know that. So thank you for explaining. Yeah, very cool. So I also, that was a bit of a diversion because I picked up on the chip question, but you were telling me about, so in 2008, 2011 is when you got your first actually commercially viable project out there. And can you tell me, well, what was that? And you said it's still in production today.
That's right. So that was a what we call a CISO mode, single transmit and single receive circuitry done on by CMOS technology, as I mentioned. And essentially that was manufactured by Jazz in the US, which they subsequently were bought by Tower, and they're now called Tower Jazz. They are a specialty foundry, and they cater for these type of circuits. That's where sweet spot is. But that chip had very little digital circuitry on it. So we had data converters and up-down converters inside that chip with various gain stages and what have you. Obviously, PLLs, frequency synthesizers. So really, that circuit was dominantly analog and RF, and you could bypass the data converters even and use external data converters because we were giving access to people to be able to feed signals to within this chip. So we try to be as open as possible so that people can adapt this technology to various applications they were looking for. But obviously, our whole mission was to democratize wireless innovation. That was the basis by which we formed the company. So a year later, we launched this initiative called MyriadRF.
Which I can bring up.
And whatever we designed around this chip, we open sourced. The modules, the boards, all that kind of stuff. Oh, there you go. That's the
MyriadRF. That's your site there. Yeah.
Indeed. And we kept it independent. We are encouraging anybody who's got any open source ideas around wireless, whether they're using our chipsets or not, to essentially make their designs available here. But the whole idea is that we started shipping this LMS6002, our first generation chip, to a lot of people out there. And we could use this MyriadRF as a means of supporting these large community of people that started using this chip.
Why did you? Can I just ask, like, why was open source, or the idea of open source, so baked into Lime from the beginning? So from the very first chip, like, what was your motivation to make this open source?
That's a very good question. Actually, we were coupling our chips together with FPGAs, field programmable gate arrays.
Okay.
These are typically field programmable digital circuitry that would sit nicely alongside our radio technology. So whatever we were designing, we were also utilizing FPGAs alongside our radio.
This back in 2003 and onwards, you were using FPGAs?
Well, we were using FPGAs for a long time, even in when we were providing design services for our customers. FPGA and prototyping using FPGA was the kind of a core of our activities.
Of course.
Even back then.
But there weren't open tool chains back then, were there? So you were using the because they didn't come until like the 2010s. People started working on that at the earliest. So what is it like now? Do you use FPGAs with open tool chains now? Like,
no,
is that...
actually, just to kind of emphasize the fact that just going back to the reason why we open sourced, our aim was to essentially follow the same business model as FPGAs.
Mm-hmm.
We like the fact that people can access them. You know, an individual could go and buy one FPGA device and do something with it. Mm-hmm. So it wasn't because FPGAs were open source, but because we liked the model. They democratized the world of digital technology and ability to program different functions. And that's exactly what we wanted to do in analog and RF domain, i.e. in the software defined radio domain. So we were a small outfit in comparison to the FPGA guys. So we had to find a very innovative way of essentially gathering the developer community around this concept. So the reason we open sourced our parts was to encourage people to design around this type of concepts, be able to modify our designs to whatever applications they wanted to cater for. And as a result, have even individuals who are interested in radio technology and in particular software-defined radio be able to experiment with these type of technologies much in the same way as they can experiment with an FPGA.
Interesting. Yeah. I mean, and of course, the world of FPGAs has become a lot more democratized since getting the open tool chains and like really awesome, languages that you can use, like high-level languages that you can use to work on FPGAs without necessarily being an FPGA engineer. You know, it's really fun to watch people playing with this stuff in Python even.
Exactly. I mean, in a nutshell,
cool.
the open source strategy came about as a result of us trying to essentially democratize the radio. And FPGA guys gave us a very good example in the way that they were conducting their business, supplying their FPGAs to universities, providing them with design kit, and obviously they had very large infrastructure to support all of that. We didn't. As a result, the open source initiative helped us to really scale up without having to essentially expand our company to the size of these FPGA guys.
Sure. I do have a couple of follow-up questions on that, but before I do that, I would like to say if anybody who's watching has any questions for Ebrahim or myself, please just pipe up in the comments, because we'll be happy to answer those for you. Okay, so was that? I'm always very curious about how people have made open source work for them, especially in a successful business, right? So, have you ever had any pushback from investors or business advisors on open source being so? It's very much baked into Lime Microsystems. So that was one follow-up question. And then another follow-up question was, how did you manage that community? Like, how did you find the people in the first place? And then how did you manage their contributions?
That's actually a great question. I mean, we set up our business with open source in mind. Essentially, we knew the power of essentially adopting that kind of a strategy. But we essentially raised a lot of money to make these chipsets. So
at what point and where from?
Right from the outset, we essentially lucky enough to be able to attract venture funding for the company.
And was that from the UK or the US? Where are you getting that funding?
From the UK. And it got followed up to the point that back in 2014, Altera invested in our company.
Oh, yeah.
Because they could see the combination of FPGA and software-defined radio is very meaningful to a lot of customers out there. So there were quite a set of rounds of funding to be able to create these chipsets. However, I would encourage any business to have an open source strategy, even though they are actually focusing on very specific customers to get really volume. Reason being that essentially open source brings talent into the field. And and software-defined radio and radio technology, there are far fewer people that are interested in that area when you compare it to digital technology.
True.
So if you are working in these kind of areas where essentially there are not many people out there today that are focusing on this kind of products, it would be an excellent way of bringing those people on board. And also, I should say that we learned a lot from this community.
Of course.
Exactly. There are, essentially, at some, I would say, I would go as far as saying that they have a huge influence on our roadmap.
I mean, obviously, this is a story that I hear fairly regularly from the creators that I speak to, just how invaluable and the expertise that you get access to by open sourcing your work is incomparable. Really, you can't buy that kind of expertise. You have to, work it in.
Indeed, and a lot of them have got their own day job that they work in related organizations. I mean, in organizations that do these kind of things, and they use their spare time and they do some really cool stuff that essentially I should say that we've learned a lot from over the years. There are a number of projects that we benefited from, and we started promoting them to our key customers even, which led to them adopting those kind of solutions, whereas as Lime, we would may not even have thought about doing that kind of stuff. So it's been very productive way of us executing on our roadmap and getting more projects that could lead to even higher volume for our product.
And how do you manage your contributors? Is it all done through GitHub, or do you have your own like hub? Do you use your MyriadRF? Like, how do you manage all of that work done by open source contributors? Because it can get quite messy, right?
Indeed. I mean, you just can't open source something and put it out there and expect something to happen. So when we created Myriad, we essentially started publishing our designs. They are on GitHub. We've got a community manager, Andrew Back, who manages that site and essentially collects feedback. And the first year or so, we were actively involved in supporting a lot of the developers that were coming to that website. So over the years, actually, people are helping each other. We are also very much involved. But we do spend quite a bit of time in supporting these projects that gets launched on the website, or making sure that we answer questions. But I'm glad to say that a lot of these are also answered by the community members.
Oh, really? See, that's once you get that critical mass of community members, you really can massively reduce your support bill. That's true.
Absolutely.
That's super interesting. So I've brought up the GitHub page here, and for those of you that didn't see, so if you go onto the MyriadRF.org, in the top right-hand corner here, we've got a forum, we've got a wiki, and we've got a GitHub there. That we're talking about. Look at all these people. Lovely. 128 followers. That's very good. Oh, you're in Guildford, are you? That's nice.
I mean, you've got a forum that is quite active also, and people are posting questions, and there's quite a few topics that people...
Yeah, this is pretty... Yeah, there's a... Oh my gosh, you had all this. That's cool. So if people want to actually contribute, the best place to go is the GitHub. If people have questions about usage, I guess the best place is the wiki and the forum. Am I correct?
That's right. Yeah. People do post a lot on the forums if they have got any questions. There are different topics that they can sign up to. The first one the first project that achieved a lot of attention was the LimeSDR that was launched on the crowd supply instantly.
That's this one here.
Yeah, that's the LimeSDR. That's the one that was launched back in 2016. It was.
Oh boy, that is quite a total. Look at that.
Yeah, that was.
You hit your goal. Let's put it that way.
That was a big. I mean, that shows that there is a huge appetite for these type of solutions.
Yeah, no, absolutely.
And as you know, there are many SDRs available out in the market now. It's a totally different landscape to what it was back in 2005.
In what way?
Well, there was very few SDRs around at that time, and they were not certainly affordable by a lot of people out there. So since 2009, I should say, we saw that these activities started to grow. And by 2015-16, there was a large community of people out there already that were making use of SDRs. So in fact, the first time I came across crowd supply was back in 2015, and we discussed the potential of launching something like this. And I think this campaign came about back in 2016.
Were you surprised by the success of it, or were you always expecting it to be a runaway success?
Absolutely. I mean, it was quite a if you like, revelation for us. We had some tier 1 customers at that time that we also encouraged to sponsor this campaign. So if you look at that time, and a large operator called EE.
Yeah. I remember them. They were a mobile phone company, right?
That's right. They actually got acquired by British Telecom here in the UK.
Oh, I didn't realize that.
And they were one of the sponsors. So it just goes to show that if you've got a strategy of open source and democratizing a piece of technology that is used by a tier one customer, they are also incentivized to make it happen, because they know that the more people make use of the technology is better for them too.
Of course, that makes total sense. So that was your first one, and it did enormously well. Which was next? Was it the Mini? Or
that's right. Then I think just over a year later, I was having a discussion again together with Josh, and the idea was to make a low-cost version of that, which was the LimeSDR was a MIMO solution based on our 7002 chip. And essentially it was a MIMO implementation. We went back to a CISO implementation on LimeSDR Mini. We retained the flexibility, but we came up with a much smaller form factor.
Well, you've seen very different customers for both of these people. I mean, they're very different price points.
Yes, but in actual fact, even people that are using this in a kind of a professional capacity, they are still buying these LimeSDR Minis because for a lot of applications it does the job.
Yeah.
Why to overkill? But the whole idea was that we go to smaller form factors, lower cost, and that was kind of the driver here. Again, here, European Space Agency.
I was going to say, that's pretty cool.
They said, okay, this is a really cool project. We want to sponsor it. So they contributed towards this campaign.
That's really great. I mean, actually, there's lots of open science hardware in the EU. I mean, I guess the UK is not part of the EU anymore, sometimes. But it's been really interesting to see the push for open hardware that's led by CERN in the EU. There's not really a big governmental body equivalent here in the US. So it's been really cool. And very great that you get the European Space Agency involved. Did they actually take your boards up into space? Do you know? I'm sure
they did not themselves, but it was used for in nanosat, obviously in a different form. We open sourced the board, so the board had to be redesigned. It had to have a special enclosure and things of that sort. But European Space Agency was interested because it enabled people to experiment with various wireless applications that could be of interest to them. So they essentially, as part of this campaign, they purchased quite a few units that they made available to their developer community.
I was going to actually ask you earlier, and I forgot to ask you about open source, have there been any implementations of your technology that have been not made by you? I mean, clearly you just said yes. There's this, so using so obviously it's open source, right? Have people like remixed your designs or used parts of them in things and you thought that they were really interesting or impressive?
Yeah, indeed. There are quite a lot of customers out there that are making use of our chipsets. They use our boards to design their own, or they use our gateware, whatever we implement in terms of our drivers, our FPGA code. Those are also open sourced. So our GUI, our user interface, they're all open sourced, so people can essentially pick them up and incorporate them into their own solution. However, quite a few of those people are not open source, so it goes into various products that gets shipped without actually coming back to the MyriadRF. So there are quite a few products out there that are shipping in some volume, but they themselves are not open source. So what you see Lime putting out there is all open source. So that's why you see a lot of our designs essentially made available to the community. However, there are a number of projects out there that essentially came about, and we helped those organizations or worked with them to open source a solution. One example is a partner of ours called Fairwaves. Essentially launched a product, a embedded version of a SDR. If I recall correctly, it was back in 2018.
Very interesting.
And it's actually on the crowd supply. That board was not open source, but we picked it up after a number of discussions with them. We picked it up this year, and we essentially did a revamp of it. We redesigned parts of this to use the components that were no longer available or end of life. And then we came up with a new version of that that we launched this year. And this board is now open source and launched on the crowd supply. It's called LimeSDR XTRX.
That's true. Yes, I can bring that up shortly. I do have a couple of questions actually around the STRX. So can we talk about FPGA choice for a little bit here? So yes. Why are you using the AMD FPGA on this new XTRX? Why? Because you've used different ones before, so I'm really curious to know like why you've chosen the.
That's right.
Actually,
the first SDR that we launched was actually using Altera, Cyclone 4. We were quite familiar with the Altera FPGAs. We were using them quite a lot in our projects. And when we used the Altera chipsets later on, requests were coming from the community asking for a Xilinx or AMD version.
So you were at the community themselves were asking you to move towards an AMD, Xilinx as it was.
Well, actually, people wanted to have a choice.
Interesting.
There were people that were not were kind of had no issue with using Altera or Xilinx, but we felt that there were quite a few people that knew how to make use of the Xilinx chipsets. They were familiar with the tool chain, and essentially a lot of it actually came out of various educational establishments that we were working with. So we said, okay, the next board we're gonna do with Xilinx. In fact, there are a number of projects that are running concurrently today that makes use of the AMD. And
projects that are coming up,
projects that are either coming up or they are in active. These are customer projects.
Oh, I see. Sorry, customer projects. Yeah. Okay, cool. Very cool.
So.
I mean,
we had to build the expertise that meant that we should be using various FPGAs, and the community or the customers would make that choice.
Absolutely. Well, actually, this is a great follow-up question here. This is actually a question from Josh, who's been pinging me in background. So Josh, that you've been speaking to over the years, is actually my boss, and he's got this question for you, saying. So obviously XTRX isn't actually a standalone device. It's meant to be embedded in other devices. And he's really curious to see what applications you have seen and what applications you expect to see.
That's a great question. In actual fact, there are quite a few people have shown interest in XTRX for the embedded applications. We work very closely with Vodafone here in Europe, and one application is to actually do a 5G network in a box solution. So they made an announcement. I don't know, Helen, if you would like to essentially put this into the.
What would you like? I
can. Chat. There's a link that you may want to share with.
Send it over to me. I will share it with the people.
Yeah. So essentially, this XTRX was put together in a solution that uses Raspberry Pi for baseband, so this XTRX has been coupled together with Raspberry Pi to create a totally programmable solution for a 5G network in a box. Obviously, with limited performance. I don't know if you're familiar with this new standard for 5G called RedCap.
I'm not. Do you want to talk a little bit about that?
So this is a reduced capability 5G with lower bandwidths. It kind of occupies the space between IoT that has much lower data rate or bandwidth, and a fully fledged 5G network for various applications. These could be used for enterprise type of network in a box solution. So the entirety of the 5G baseband as well as the core network essentially has been implemented on the Raspberry Pi. Coupled with our radio, then we have a solution that could be deployed out in the field. So that's one application that has caught the imagination of a large operator here in Europe that essentially was quite keen to showcase this at Mobile World Congress this year.
That's super interesting. I'm going to put the link into the comments or the show notes if you're watching this later. Very cool, very cool. So we've taken a look at that. I think I had another 1 second. I had a question. Unless you wanted to talk a little bit more about the XTRX, I wanted to talk about your chip design, because you're a fabulous company, right? And you're making this. You're making this LMS7002.
Yeah.
What is next? Is there something next? Like, what are you doing? More silicon? Like, what's the plan?
Yeah, I mean, when you are making SDRs of the kind that we make, there is a kind of these chips. We never end of life any of our chipsets because we do know that the demand for these goes almost forever. People are using these chipsets, but there is the next chip is called LMS8001 that we will be launching next year. Basically, the idea here is to extend the frequency up to 10 gigahertz. So LMS7002 and 6001 goes up to 3.8 gigahertz. So LMS8001 is an up-down converter that takes a IF frequency, an intermediate frequency, and up converts it to any frequency up to 10 gig and vice versa. So it's an up-down converter that essentially extends the frequency range. I mean, if you are in the SDR world at a very high level, your roadmap is very simple. You extend the frequency range. Obviously, we're going to go up to 100 gigahertz as we go through our roadmap, but also improving the bandwidth. So we went from 40 megahertz from our 6002 version to 100 megahertz bandwidth in 7002. And the idea is to extend this further to 400 megahertz and beyond. So bandwidth and frequency of operation is what determines our roadmap. And that's what we continuously do as we go from one generation of the chipset to the next.
That's really cool. Talking about going from different generations, do you want to have a little look at some of the other ones? We took a look at the LimeSDR, which was your initial one, and we got the SDR Mini. We had there's quite a few different things here, plus a couple of things that are coming soon. So I wonder if you could, if there's anything here that didn't you have a bunch of trouble as well with the Mini 2.0 during the horrible chip crisis. Yeah. So tell us about that if you want to commiserate or.
Yeah, I mean, literally, we could not really ship any back in 2020 when we went into the lockdown and all those problems with chip shortage. It wasn't so much our own chipsets. Obviously, we had inventory. But when we make these boards, we make use of a lot of other chipsets or components that were simply not available.
No.
And there were components on those that estimated delivery were quoted as over 2 years. That we were in that kind of a. So basically, we almost stopped shipping any SDRs.
At all, not just the 2.0, the Mini 2.0.
Yeah, it was. I mean, we shipped. Yeah, we shipped as many as we had in the inventory, or we had parts for. Once those finished, then essentially we didn't have the components to ship any of these. So
what did you do? Like as a company, what did you do?
Well, I mean, obviously we had customers who were buying our chipsets for their own products. So, but as you know, if you cannot ship any products, then basically you are not able to, and you're not able to get hold of the chipsets. Then I would say we went through a very, very difficult period. But we were lucky for the fact that we were able to sell our chipsets to the tier 1 customers of ours. And we had a fair amount of inventory during that period.
Did you do a lot of design work?
We did a lot of design work for our customers, but certainly a lot of essentially semiconductor companies of our size, I do know that some of them couldn't make it as a result of these issues. But putting those difficult times behind, we did essentially spend a fair amount of time looking at our SDRs, and we decided to shift the LimeSDR Mini, which was based on an AMD chip at that time, to ECP5 from Lattice.
Yeah.
So
was that just availability, or was the tool chain a factor in that?
Both. So we've got a very good relationship with Lattice. Certainly, they've paid a lot of attention to us over time. And since we had AMD and essentially Intel or Altera solution, we decided to essentially have also a Lattice version. We are covering all 3 major FPGA providers with our solutions.
That makes total sense.
So here I should also thank Lattice for doing everything they can to provide us with the chips that we wanted for the delivery of the LimeSDR Mini 2.0.
When you say doing everything you can, do you mean to try and get you the actual parts?
Yeah. Parts, exactly.
Yeah.
Exactly. And also helping us to make the shift, because, it's a new tool chain for us, a new experience with a new FPGA. So we had lots of questions, obviously, and their application team were on hand to answer our questions. So that was another reason that made the journey very somewhat painless. But I'm happy to say that we've just delivered quite a few of these to crowd supply. Yes. So there should be a significant amount of inventory for people to get hold of these LimeSDR Minis very quickly.
Yeah, in stock. Look at that, in stock. We like that little label there.
Indeed.
That's very cool. You probably get a run on those now. Do you know how much stock we have? Have we got enough?
That's a question for Josh and the team. But I think I know there were quite a few pre-orders already, so I'm expecting a lot of those have already left crowd supply or about to.
Yeah, very cool. No, we're excited about that being in stock as well. All right, I'm conscious of the fact we've got about just over 5 minutes left until the end of the stream. So is there anything that you'd like to go over, like to share with the audience or future viewers? Or is there any call to action? Do you need people in specific areas to help you develop things? You know, now is your chance to ask people for things that you want. Or promote, you know, I mean, I've shown your GitHub, of course, and I've shown the MyriadRF as well. Are those the two places mostly where people interact with you, or are you on the old social media as well?
Yeah, we are, but essentially we do encourage people to communicate to us through MyriadRF purely because there is a community there, and I'm really pleased with the way that the developers are interacting with each other. And obviously we step in if there are questions that are not answered or people want to specifically talk to us. All of these forums are constantly monitored, and we essentially aim to make sure that people get their questions answered. But you know, it's important to say that software-defined radio is, in my view, still is at the beginning of its journey.
Nice.
And I believe as essentially we go forward, it will gather a lot more momentum. So I do encourage people to study the field because wireless at the end of the day is an important part of our lives. We deal with it every day. We may not be conscious of it, but this is a technology that we use every day and we rely on it in the sense that everything we do essentially relies on wireless technology in one way or another. So understanding the technology and essentially experimenting with it, I'm sure will bring new ideas into the field and enables it to expand much in the same way as processor technology or digital technologies today is fully democratized, and we see lots of innovation happening in the field.
Yeah. So it's definitely a field for young engineers to get into.
Absolutely, that's exactly what I. So if you're studying electronic engineering, or if you're in that kind of a field, even I would encourage you to essentially study the field and try to get your hands on SDRs. There are lots of them available in the market, just not Lime. So depending on your budget and what you want to do, I would encourage people to experiment with this technology. And as I said, I do see the next 10 years as being pivotal in terms of getting the community to expand and essentially democratize this field of wireless technology that today is very much in the hands of very few people.
Very cool. And what can we watch out for from you over the coming year? Aside from this new exciting chip, what else have you got on? Have you got any more boards coming out? You know, any sneak peeks of things that you can share with us?
Well, at the moment we are averaging one campaign a year at least. So you would expect that we would be launching one or two campaigns around some of the ideas that we've been working on. I think people will be pleasantly surprised with what we've got planned in terms of getting the technology more accessible and coming up with a more complete solution that people can work with and trying to take the pain away, because it's not easy working with SDRs. There are lots of parameters to play with. So it requires a lot of work to get it to a way that it does something useful. So we are kind of constantly thinking about making it easier to use and making it more accessible. So 2024, you would expect us to be launching more campaigns, at least one that we are working on just now to make this field more accessible and democratized.
Well, I'm very excited to see what you come up with. All right, it is 1 minute to 10, so it is time for me to say goodbye to you. Let me just take this out so we can see your lovely face before we leave. All right, thank you so much for joining us, Ebrahim, and telling us the story of Lime Microsystems. We got some great insight there into some of your design decisions and your history as a company as well. So thank you so much, and we know we're all very excited to see what you come up with next. You're an institution at Crowd Supply, so we're very excited to see what your next campaign will be. So thank you so much, and thank you for the people who are joining us at home as well. And you can find out everything you need to know at the below URL, MyriadRF.org. That's got links to the GitHub, that's got links to the wiki, that's got links to the forum. There's also, you can obviously go to Crowd Supply to check out all of the different things that are there. You can pre-order or purchase. So again, thank you so much, Ebrahim. And thank you for watching. Next week I will be in San Diego, so there's no stream next week. But the week after that, I'm planning on talking with Joey Castillo of the Sensor Watch, and he's got very exciting news about his open book project. So I'm looking forward to catching up with Joey there. So hopefully see you in a couple of weeks. And thank you for watching, and adieu. See you, and happy holidays as well. Bye. Bye, everyone.